Hello मेरे बच्चों, welcome back. Exams are near. Tension नहीं लेने का. We are going to revise this entire chapter in just a few minutes.
I promise your favorite tutor is here to make this chapter ekdam simple for you. By the end of this, you'll feel super confident. So let's get started. First up, let's imagine a big wrestling match. In one corner, we have the mighty metals, and in the other, the non-metals. It's time for the great physical face-off. And here are our contestants. On this side, representing Team Metal, we have the strong and shiny Mr. Iron. And his opponent, from Team Non-Metal, is the dull Mr. Coal. They look so different, don't they? So what is the big difference between them, really? It's not just about looks, you know? We're going to do some super simple tests to find out what's really going on. Let's begin. First test. The appearance test. Just look at any metal. It has a special shine, right? That shine is called luster. So metals are lustrous, and they're generally hard. But non-metals like coal, they look dull, no shine. So we say they are non-lustrous and usually pretty soft. Easy. All right, next round. We call this the hammer challenge. The proper science word is malleability. It's a very simple idea. Can you hit something with a hammer and flatten it into a thin sheet without it breaking? If yes, it's malleable.
And you see this every day. That super thin, shiny silver foil on your favorite mithai, that's a metal. And the aluminium foil used to pack your food, that's also a metal, beaten into a thin sheet. This is malleability in action.
Okay, on to our next challenge, the stretching challenge, or as scientists call it, ductility. This is the amazing ability to be pulled or stretched into thin wires. Think about the electrical wires in your house. They're made of copper because it's so ductile. Just how ductile can a metal be? Get this, just 1 gram of gold can be drawn into a wire that is 2 kilometers long. Can you believe it? That's why gold can be shaped into such fine and detailed jewelry. Amazing, right? Okay, time for a quick exam question. This one is very common. Why are school bells and temple bells always made of metal? Why not wood? What do you think is the special property here? And the answer is because metals are sonorous. It's a fancy word that just means they make a ringing sound when you hit them. You strike wood, you get a dull thud. You strike a metal bell, you get that nice ringing sound. Simple. Okay, let's move on to the next big challenge. This one is really, really important. The conduction challenge. We're going to test if our contestants can handle heat and electricity. Let's test for heat. Imagine you put a metal spoon and a wooden spoon in a cup of hot water. After a minute, which handle is hot to touch? The metal one, of course. That's because metals are good conductors of heat. That's why your pressure cooker is made of metal, but the handle is plastic. Now for electricity. Have you ever noticed an electrician's screwdriver? The tip is metal, but the handle is plastic. Why? Well, electricity flows easily through metals. They are good conductors. But plastic, a non-metal, is a poor conductor, which keeps the electrician safe from getting a shock. So far, we've only tested physical properties. Now, for the ultimate chemical test. We're going to see how our metals and non-metals react with the oxygen in the air and with water. First, metal plus oxygen. When we burn a magnesium ribbon, we get a white ash. That's magnesium oxide. Now for the real test. We mix this ash in water and put in red litmus paper. And look, it turns blue. And what does that tell us? It means metallic oxides are basic in nature. Remember this. Now let's try a non-metal, like sulfur powder. When we burn it, it makes the gas. We dissolve that gas in water and test with blue litmus paper, and it turns red. So it's the opposite. This tells us that non-metallic oxides are acidic in nature. One is basic, the other is acidic. So simple. Now, you might be thinking this is good for the exam, but does it really matter in my life? Oh, absolutely. These properties are all around you every single day. Let me show you how. Just think about non-metals. Oxygen, which we need to breathe, is a non-metal. Nitrogen, which helps our food grow, is a non-metal. Chlorine, that purifies our drinking water, is a non-metal. Even the iodine we put on wounds is a non-metal. We can't live without them. And we have covered so much. Feeling like an expert? Good. Now for the most important part. Get your phones ready to take a screenshot, because here is your final exam revision sheet. And here it is. This simple table has everything. Luster, shiny versus dull. Malleability, yes versus no. Ductility, yes versus no. Conduction, good versus poor. And nature of oxide, basic versus acidic. This one slide has the 5 key differences to help you score full marks.
And that's it. See, I told you it was simple. You are now an expert on metals and non-metals. You have totally got this. Go into that exam with full confidence. All the best for your exams, mere bachcho. You're going to do great.